Hi, this is Joey Gugliardi, and this is my Monte Carlo 2 lab for intractable integrals assignment. So as you can see, I have just kind of some of my pseudocode here, and I'm just kind of defining some of the variables. The rest of my pseudocode's found down here, and I also have my MATLAB code here. And basically, what we were doing in this first assignment was to find the area of the portion of the circle that's found in the first quadrant of the graph that's between coordinates 1, 1. And so we jump on over to MATLAB. I'm actually going to run this for 1,000 iterations instead of 1,000,000, which is what it would say. If we ran it for 1,000,000, it would converge more, but just for the sake of brevity, I'm going to do it for 1,000. So we define 1,000 random variables, have a count going on here. The area of that section is 1, the radius is 1. So we go through the loop of 1,000, and if basically what this if statement is saying is if that coordinate happens to fall in the circle, the count would go up, but if it doesn't, it won't. Basically, we'll take a percentage from this out of 1,000, multiply that by the area of the square quadrant, and that will give us the estimated area. So we'll run this. As you can see, we get an estimated area of 0.797, and actually pi is estimated to be 3.18, which obviously is off, but that's because we did 1,000 iterations. When you run it at 1,000,000, it's much closer to what pi actually is. And solving the equation down here, the area of the circle for pi gives us this number here. So that was for the first part, and basically what you learned from that was how you can use Monte Carlo to calculate the area of any curve, area underneath any curve, which we just demonstrated with this example with the circle. So the second pseudocode assignment, I have the pseudocode here for the second assignment, and basically the result was to show how Monte Carlo can determine the area under a curve of an equation given a distribution, and you can use any distribution. For this example, we did a random exponential distribution. So I have both my pseudo and MATLAB code in here. So jump over to MATLAB. We have our random number generator here. We have, here it is, this section here. Random number generator, 1, 2, 3, 1,000,000 iterations. This is MATLAB's algorithm, so we're going to solve the integral just using MATLAB, and then we're going to do it using a random exponential and using a change of variable with the Jacobian to see how this will work doing it with Monte Carlo as opposed to just integrating the function just straight up in MATLAB. And so as you can see, when we run this, we get a area from MATLAB of 0.8056 and an area from our equation using the distribution as 0.8040. And as you can see, these are very close to one another, and they both fall in between the upper and lower limits. So we've shown that we can use Monte Carlo to solve an integral equation using any distribution. And we actually did this example for the normal distribution and also the uniform distribution. So that is pretty much all I have. Thank you for watching.